I'd like to start off by asking the panel this question. On a disruptiveness scale of 1 to 10, with 1 in disrupting an IT environment being a dot release of new software to upgrade, and 10 being the move from mainframes to client server, what number would you give for OpenFlow networks? Anyone? And why?
OpenFlow in particular, or SDN in general?
SDN as advanced by OpenFlow.
I would say probably somewhere around a 7 or an 8. It is, Scott, I think, said it earlier today. This is like the move from mainframe to Linux on blade servers. This is the capability to do that. Is OpenFlow that 7 or an 8? Not yet, but it lays down the groundwork to get there.
Anyone else? Go ahead. Your mic's still on.
Oh, yeah. So, yeah, I'd say that overall there's a sort of bigger force that SDN is riding, which is kind of what's happening in the cloud and the data center. And, you know, the disruption, and I think Nick said this also, first came from sort of the ASIC manufacturers like Broadcom that sort of created this, this horizontal sort of disaggregation of the industry, and then you had sort of companies like Arista that were able to take, you know, on different ASICs, the same operating system really quickly. And so something very interesting was happening just from larger industry forces that enables the OpenFlow movement. And I'd say that really is the 7 or 8, that larger sort of industry change.
Okay.
Yeah, I would add to that, and I would agree with what Albert said. I think that there's a larger trend going on, which is really the move to cloud computing and everything that entails in the data center, which is about viewing the physical infrastructure as supporting applications and dividing the line there between the data center versus the applications, as opposed to the traditional IT approach, which is dividing things between network, servers, storage, facilities, applications. By viewing the data center effectively as a service, this is what I see going on in many of our large customers, not just the obvious public cloud providers, but many companies running big data centers today, even for their own internal applications, are more and more taking the view that their data center team is a service provider to their application groups. And in that context, that's what I would say is the 7 or 8 sort of level of disruption in the way people are approaching building large-scale applications, the way they're staffing and administering them. And OpenFlow clearly plays a role here in giving the data center team additional tools to automate their network, to define policies and procedures for allocating load, allocating capacity where it's needed according to their commitments as service providers. So that's where OpenFlow plays an important role. But I would say it's part of that larger trend.
Okay. Again, we're talking about SDN and OpenFlow as bringing to the network the dynamic architecture of the virtual environment. How does networks as currently configured and designed and running inhibit the benefits of virtualization in the data center, and how would SDN overcome those limitations?
So
Samrat?
So one of the things, what I was trying to mention here is that one of the difficulty, if you see, or the difference you see between the server storage and the network is that server storage can be considered as separable elements. You can group them servers, you can cut them into pieces, but network, because they're talking to each other, you can't cut them into pieces. And because you cannot sort of aggregate them in a resource. And if you cannot aggregate them into resource, you cannot virtualize them also into a single block or a larger block and sort of hide the whole problems there. So that's the OpenFlow. What it is doing is by directly centralized way of connecting to each of the entity into the forwarding level engine, it is taking out the entire distributed part of it directly from the switches to talk among themselves, which allows them to virtualize them.
Okay. Anyone else want to comment?
Yeah, I'll comment on that, which is that I would say that the network is not doing as much as it could to support the modern data center operator, in that it's not adequately supporting the data center operator's ability to place load, to place workload, to place storage wherever it fits to bin pack across the entire data center, or even multiple data centers, because the network architecture is interfering with what the data center operator is trying to accomplish. The most obvious example of this is the fact that you can only move virtual machines within the layer 2 domain, but trying to make your layer 2 domains too big and too wide leads to severe scalability problems involved in MAC address capacity in your core switches, or spanning tree, or multipathing, whatever. There are many limitations that you hit when you try to make layer 2 domains too big. And where network virtualization can play a very important role is decoupling the topologies as seen by the applications and by the services from the physical topologies that data center operators are nailing down with fiber optic cables. Once those are decoupled, then the application, any part of the application can go anywhere, and the network has to provide this. And where SDN fits in potentially here is in scaling the control plane required to keep track of where everything is, because the amount of state required to get every packet to the right place when you have thousands or hundreds of thousands of layer 2 endpoints or even layer 2 topologies all intersecting across the same physical network becomes quite large. And perhaps through central management of some of that state, we can better scale it.
Mr. Pitt has a question?
Yes, I have a question. Clearly, the move to cloud computing and public and private data centers is happening with or without SDN. If you were to imagine its growth without SDN, we can see that that's going to be pretty important. How much more will it grow because of what you can do with SDN?
Good question.
So, yeah. So I don't separate it that way, to tell the truth. I think that kind of the message of my talk is that that SDN is consistent with how we manage large infrastructure. So we wouldn't do it without SDN. If I understood your question, and then I really wanted to focus on some of the immediate pain points where the existing protocols and capabilities of the physical network are lacking. I think if we can solve that, we can increase the reliability quite a lot and help lower our cost and manage capacity and so forth. There are other scenarios like that are all new, I guess, that one that Nick mentioned was this customized peering, for example. And that kind of thing, when you're trying to trick the existing protocols into doing that, it just can be brittle or impossible. And for that, you do need software control, new software knobs. And the alternatives that cloud providers, for example, have today are to do it themselves, essentially, or in the future to use an SDN controller.
We have a question on stage left over there.
Fred Lima with Visa. How are you guys addressing or planning to address in the context of SDN storage networking? You expect switch vendors to provide switches that are DCB-enabled switches? Do you see as a virtualized, abstract level that you want to control at the controller level? Or how you think that's going to be addressed? How are you thinking about it?
I honestly think that that's going to go away. I think more and more storage is moving into IP-based, and the requirements for DCB will just slowly trickle away. You're going to be using abstractions like what Amazon S3 or other types of things. So I just don't think they're going to be needed for very long, where very long is measured in years or decades.
We had a question on the right here.
Okay, Alex Bakhmatsky with Ericsson. A question, probably I start with Igor from Yahoo because it's your slide, but I know the question is a little wider. So on your first slide, it was kind of ideal slide where you extract control plane and you leave management plane and data plane in the forwarding element. So I will pick up that slide and ask a few questions that are related to it. So the first question is related to control plane versus management plane. Especially taking into account that today we had one presentation that actually, I know there was somewhere there for the slate architecture, noted, which is actually pretty much tightly coupled management and control, or at least much tighter couples than what you presented in your slide. So the question is here, what is the relationship between control and management, and whether there are any plans actually to put that as a part of SDN principle?
I think we have somewhat of a term overload. In that slide, by management, I don't mean that you SSH into a device and you manage it that way. By that, I mean in a modern router or switch, control plane says, I have a rib, and I decide where things should actually go. The management plane is what translates the rib to the fib. And that's what I meant. It's just that little interface that takes this is what the rib looks like, and here's how I convert those instructions into the assembly level stuff of where the bits go.
Okay.
So it's almost like a driver.
Okay, so it's a little different terminology. Okay, so the second question is related to the control plane itself. The slide is very idealistic, where the entire control plane is extracted outside, which is probably too idealistic. When we look in realistic scenario, I know in this case we cannot build even a network topology because I know there should be some entity that builds automatically network topology. So whatever the protocol you build, link state protocol in routing or any other way to build network topology of the forwarding elements, you will need to have at least that portion of the control plane there. And it comes also to the second part of that question about control plane. What if you have network that some elements actually, some forwarding elements do support OpenFlow and some don't? So how you deal with the heterogeneous network of SDN?
So I guess, let me see if I can get all of them straight. So as far as that slide being somewhat idealistic, I actually don't think so. If you look at Hadoop framework and MapReduce, we've learned how to control many, many different objects, and we've learned how to keep them in sync, or at least the system theory guys, the application developers have. The network state distribution is ultimately flood and learn, and that is incredibly inefficient in keeping a consistent state machine. So what I'm talking about is basically taking the lessons learned and all the algorithms and whatnot that came out of the systems theory and actually applying it to the network. So yes, we absolutely can create that map of 2.4 million elements and keep it in sync across several thousand devices. That's not a difficult computer science problem. That's difficult with networking because networking is approaching it from a fundamentally different perspective. As far as keeping the network graph intact, knowing the connectivity model, you can look at it from two different perspectives. You could say that you could actually segregate them as a recursive algorithm and say that I know where every ARPA MAC in my network is, and the way to get to that ARPA MAC is to go to switch 13, and then something that runs on the network elements themselves compute how to get to switch 13. So every lookup is a two-stage recursive lookup. That's one way of doing it, and that may be the best way to go. The other way of going is I have a little agent that runs on every switch that literally ping tests its adjacencies, and then reports that up to the controller, and controller says, I know exactly who you're connected to. You have 20 of 24 links up to the following things. I have the graph. I'm not going to distribute that information. Again, if you look at how MapReduce framework works with Hadoop, and HDFS and the insane amount of storage that lives in a cloud that has to follow the same type of name node constructs, this is a fundamentally solved computer science problem.
Okay, thank you very much. We have a questioner on the stage left.
Hi, I'm Steve Georges from Line Rate Systems. I have a question for large mature networks like Yahoo's. How do you imagine first introducing software-defined networks, and then how do you see them rolling out and ultimately replacing today's infrastructure?
Off to the side, ships in the night, and then I mean that's honestly, it's off to the side, ships in the night, and we do tend to replace our infrastructure every several years, and If this works out, then this is actually the perfect time. As 10 gig to the server is actually finally becoming a reality for deployment, this is the greatest time to get something new going because we need to be swapping out the infrastructure anyways.
Thank you.
This gentleman is going to be the last questioner.
Okay, so I'm going to try to make it interesting. So I'm Samuel, and I have a very open question to the 5 panelists. I'm sure you are running OpenStack or looking at OpenStack, and I would like to know, how do you see the two OpenFlow, OpenStack? Do you see a convergence? What are your thoughts in terms of how do you see the future around these two projects?
Interesting question, because I'm working on an answer for that too. If you look at, there's a lot of presentations going on today about doing per flow programming. I absolutely do not see that scaling in a large-scale data center. I know I've just pissed off half the room, but I'm sorry, that's the reality. If I look at a rack of my servers, I have 40 servers, let's say 20 VMs per server, so there's 800 entities in that rack. If every one of them is running Hadoop on a tiny cluster of only 4,000 nodes, that is 3.2 million things that are talking to each other in that rack alone. You absolutely cannot be doing microflow programming of that at my scale. What you can be doing is doing endpoint programming, as in you're talking to these X amount of thousands destinations, and I can program that. And the best place to program that is probably into the vSwitch directly and not into the physical hardware. You let the network be a dumb, fat pipe, and you put the intelligence on the server that has the memory and the CPU to actually do it. So I guess kind of my answer is the quantum portion of OpenStack that will probably integrate into the Open vSwitch, and you're going to have Open vSwitch, which is already capable of being OpenFlow controlled. Some smart vendor out there that is in this room will probably figure out a way to control all those Open vSwitches and make it all work.
All right. Another round of applause for our panel.